An AI accelerator can perform an enormous number of calculations, but a useful AI system needs thousands of chips to exchange data. The surprising bottleneck is often not the arithmetic. It is moving bits between processors, memory, switches, and racks without consuming too much energy or waiting too long. Electrical signals travel through copper traces and cables. At short distances, copper is familiar and effective. As data rates rise, the signal becomes harder to preserve. Designers use stronger drivers, equalization, and more power to push clean information through the channel. Heat rises, and the link itself begins taking a larger share of the system's energy budget. Optical communication sends data as light through fiber. It can carry high bandwidth over longer distances with lower loss, which is why data centers already use optical transceivers between switches and racks. The next question is how close the optics can move to the computing package. In a traditional pluggable design, electrical signals travel from the switch chip across a circuit board to an optical module at the edge. Co-packaged optics places optical engines much closer to the switch or accelerator, shortening the difficult electrical path. Silicon photonics helps manufacture optical components using techniques related to semiconductor fabrication. Waveguides route light on a chip. Modulators encode data. Photodetectors turn light back into electrical signals. Lasers may be integrated in different ways because generating light efficiently on silicon is difficult. Moving optics closer creates new problems. The package must manage heat from both compute and optical components. Fiber attachment has to be precise and manufacturable. A failed optical engine cannot be as easy to replace as a module plugged into the front of a switch. Testing becomes harder, and the supply chain must assemble photonics and electronics with high yield. This is not about replacing every copper wire with light. The choice depends on distance, bandwidth, power, cost, serviceability, and production maturity. The milestone to watch is energy per bit at real scale, along with field reliability and repair. Faster AI chips matter. But if the system spends too much power moving data into and out of them, the interconnect becomes the machine everyone is actually designing around.